benefits of voice over IP is going to be the new features that are available, not the actual communications. They already got that. What we're going to be interested in is fun new features like web-based caller ID and integrated messaging. The idea with integrated messaging is that we have a single interface for the human to look at email, voicemail, and in theory fax as well. Now when we're talking about email, we're talking about some protocols like the post office protocol, POP. This is the one that you use if you use a mail client like Eudora or Microsoft Outlook. You've got a mailbox and you log onto your POP server and download the messages. Another protocol is IMAP. This is Hotmail. And the idea is that you could be at any computer, so you don't download the messages onto the client and then delete them from the server. They stay on the server, so you can access your messages from anywhere. For voicemail, in older times, we used the SMDI, the Simplified Message Desk Interface, to connect a voicemail system to the telephone system. And what an SMDI link is RS-232. I don't know if anybody remembers this. This is the thing we used to plug external modems onto our PCs with. And then you could have analog trunks or digital DS0 trunks going from the telephone system to the voicemail system. And the RS-232 is the control link. So we might end up having to support that as well. Fax has got two different aspects to it. One is outgoing and one is incoming. Outgoing fax is relatively easy because you just need to connect to a fax modem somewhere that's connected onto a regular telephone line. Incoming fax, usually what we would have, a fax machine / modem / server that would receive the faxes, and then it would, instead of printing them out on a piece of paper, it would put them into some sort of graphics format and then email you that graphics page, which is the fax. The idea with integrated messaging is that the user can view all of this stuff or listen to all of this stuff in the same place. So one example would be we have what appears to be a web browser screen, and it lists all of your voicemail messages and email messages and faxes. And in theory, you could read your email and you could read your voicemail. That would require speech to text, which is kind of hard to do. Or another possibility is you could call in and pick up your phone and you could listen to your voicemail the same way we do now, but you could also listen to your email. That's a bit easier to do because that's text to speech. Sorting through spam is another question altogether. There are two basic ways to do this. One way would be to throw away all of your existing investments. So throw away the voicemail system you've got, throw away all of your POP servers and email, and replace it with a shiny new integrated messaging device from some company that handles it all. Another choice would be to keep all of your existing investments and buy some software that makes it look like this is all integrated. And this software would, in a sense, glue all of your existing investments together. So this software would be able to go to the voicemail system and find out when you have voicemail messages waiting and whether you've listened to them or not. And it would be able to go to the email systems and get your email and put this all into a nice single unified interface. You can start to think that we have to do gateway functions at this point. Remember, a gateway is a device that does protocol conversions. And you can think right now, one of the protocol conversions a gateway is going to have to do is to convert between different email servers. Maybe in this part of the organization they're using POP servers, in that part of the organization they're using IMAP servers, and we're going to have to figure out how to bring those two worlds together to be in the same type of server that our new integrated messaging system is. Maybe that's an IMAP server, so it's going to have to speak POP. So that means that we need a function that does protocol translation, so that's a gateway. To round things out and finish things off, let's just take a look at the big picture and discuss a bit about the order you'd want to do this stuff in. And if we start on the right side of this diagram, what we see is we have all of the devices, and whether they're IP phones or they're desktop computers, are all connected with a single access wire to their own port on a switch. And this switch is one sitting in the wiring closet within a few tens of meters or tens of yards of each desktop. Then these switches in the wiring closets are all connected down to a high horsepower Ethernet switch in the telephone room. Connected to this high horsepower Ethernet switch in the telephone room are all of the servers, like the call management server and the server that's doing voicemail or integrated messaging, and the servers for the applications, Oracle and all of that fun stuff. Then we connect that to a router, and the router is the device that connects the in-building communication system, this is the LAN, to external connections. If we're going to connect to the public telephone network, we need a gateway to do that. If we're going to connect to IP networks, we have to have a firewall in between us and them. And then we could connect to the internet so people can do web surfing, not for voice over IP. We could connect to a managed IP network, and then we could connect to a native voice over IP network in the future for doing voice over IP from one building to another over wide areas and have guaranteed quality of service. Now let's discuss the order in which we might proceed to try to get things working. The very first step is the physical infrastructure inside the building, because if you've got a spongy foundation you're trying to do communications over, it doesn't matter what kind of tweaking you do with jitter buffers and things like that, you're never going to get good voice quality, or you're never going to get consistent voice quality. So the place to start is with the LAN, and what we want to do is rebuild the LAN. The objective is to have from each cubicle a single non-shared connection from a jack in the wall back to a switch in the wiring closet for doing the voice. As we discussed in the pros and cons and powering story, it really is a good idea to have a separate wire to each device. In theory, you could plug your computer into your telephone, but that's kind of tying one hand behind your back in terms of tweaking and quality and also ongoing maintenance going forward. The specification should be for 2 separate cables going to 2 different jacks on the wall in the cubicle, going to 2 separate ports on a switch in a wiring closet. And then those switches get connected down risers down to the telephone room using gigabit Ethernet, either over copper wires or gigabit Ethernet over fiber, to a honking big switch. The reason why we use switches instead of routers inside the building is that Ethernet switches are lightning fast compared to routers. Ethernet switches, the only thing they do is they bring in the beginning of the LAN frame and look at the destination LAN card address in the front of the frame, do a little table lookup and send it on its way. A router has to bring in the entire LAN frame, do the error checking and any recovery necessary there, pull the data out of the LAN frame, which is the IP packet, look at the IP address, make a decision, put it back in, change the address on the frame, recalculate the error check, and send it on its way, which takes a lot longer. So we like to use Ethernet switches to build the system inside the building, and then just have one router as the interface between the in-building system and the outside world. Once we have the physical infrastructure in place, then we'd want to get some IP phones and the gatekeeper function installed and working. And we'd want to see if we can get a dial tone or the equivalent thereof from the gatekeeper. So can we actually register our terminal? Once we can get that working, then we'd want to see, can we establish a connection